Question 3.5. A mixture of alkenes is produced when pentanetol is dehydrated in the presence of hot concentrated sulfuric acid. So concentrated sulfuric acid removes water. It removes an OH from a carbon and an H from a neighbouring carbon atom. So between those two carbon atoms there's an H on one and an OH on the other carbon atom, and it removes the water from across those two carbon atoms and leaves a double bond. Pent-1-ene is one of the isomers produced. Name and outline a mechanism for this reaction. Well, if I'm removing something like water, it's an elimination reaction. So what actually happens is, if I draw pentanetol, so 5 carbons in a line with the OH at number 2, I've got a lone pair of electrons on the O, attacks H+, which is the sulfuric acid. Sulfuric acid, all acids make H+, and then what happens is the O bonds to the H and the O gets the plus. So the electrons are moved on to the H+, so it loses its plus, and the O has electrons move away from it, so that gets the plus. Then I need to break the water off, so the water breaks off and the bond breaks here, and the electrons go onto the O, so that removes the plus on the O and makes H2O, and then one of the H's on the neighbouring carbon then breaks off. It could have been this H here and made a double bond there, so there's no reason it has to be an H on the left. It could be one on the right, except the question says it makes pent-1-ene, so this will make pent-1-ene because it'll make a double bond then between the two. So that's the mechanism there. A pair of stereoisomers are also formed in the reaction in question 3.5. So as I've said, you could, instead of the double bond being here, pent-1-ene, you could have made pent-2-ene, because this hydrogen could have broken off to make the double bond here and kept the CH3 here. So if I'd made a double bond there instead, I would have made pent-2-ene. Now there's two forms of pent-2-ene, there's Z and there's E, because there's no free rotation around that double bond, so the atoms get fixed in positions in space. No free rotation about the carbon-to-carbon double bond. Each carbon in the double bond has two different groups attached, and the groups get fixed in position in space. Now, which of the two? It says a pair of stereoisomers are also formed. Name the less polar of the two. So the less polar of the two. If you have two groups on the same side, on a Z, then these groups can be polar, and so it pulls the polarization, it pulls any delta plus and delta minuses onto one side. So a Z isomer is always more polar because you've got two groups, like two methyl groups or a methyl group and an ethyl group, they actually repel electrons, but it doesn't really matter. Those two groups may be polar and it pulls the polarization onto one side. If they're opposite in an E isomer, then the polarization is spread. So an E isomer is always less polar than a Z isomer.